Very first tutorial in physics. Now, in these upcoming tutorials, what I'm going to be doing is I'm basically going to be treating this as an introductory physics course if you were to take it in high school or college or anywhere else. I'm going to be teaching you the basic core principles to get you guys started in physics. And by that, I mean I'm going to be teaching you about mass, force, velocity, the properties of matter, all that fun stuff. So that's what I'm going to be doing. That's what you guys have to look forward to. But before we get started making any weird calculations or anything like that, I think it's important to understand the definition, the proper definition of physics, and that is the study of matter and energy. Now, there's no like one proper definition of physics, but if you look around the web and all your textbooks, this pretty much sums up what physics is. Studying matter and energy and how they interact with each other. Pretty much studying all the things that you can measure. So you're saying, all right, so it's pretty much a study of like everything on Earth? Well, not exactly. So you're saying, all right, so what are some of the topics that physics doesn't touch on? Well, we're going to be talking about topics like love, physics is not going to cover, passion. I'm sorry, but if you're here looking to study passion, you're in the wrong place. Courageousness. Well, I might touch on that a little bit, but it has nothing to do with physics. So, those are some topics that, we can't measure with physics. What we can measure is like volume, the speed of light, all that boring stuff. But by the way, if you're looking for love and passion tutorials, then I might be making some of those pretty soon. But anyways, that's what physics is. That's the formal correct definition. That's what you should write on your test. So, now let's go on to the next step, and that is, well, whenever scientists are working with physics and they're working with these huge numbers such as how many atoms are in the sun, what's the speed of light. Well, first of all, I need to explain to you guys that these numbers are huge. They're like billions and billions and billions of atoms inside the sun, numbers that I can't even really comprehend right now. But we just can't write these numbers out like you would write how many brothers you have or how much you weigh, because if you try to write the number of how many atoms were in the sun, it would take you like 6 years just to write it out on a piece of paper. So what scientists did is they came up with a really lazy way to write really big and really small numbers, and that is through the use of scientific notation. Now, my definition of what scientific notation is it's basically the way lazy scientists write big and small numbers. Now, the technical definition is basically if you ever heard of power of 10 notation, it's pretty much taking a number and timesing it by 10 times a certain power. And well, let me go ahead and throw you guys into a nice example right here. So let me go ahead and get my new stylus out. What color am I going to choose? Blue looks pretty good. So let's say we had a number like 28,700 and we wanted to express that using scientific notation. Well, what we would do is we would write 2.87, and by the way, I know my handwriting is really bad. You guys are just going to have to deal with that. So 2.87 times 10 to the fourth power. So this is basically the basics of scientific notation. You have a number on the left here and you multiply it times 10 to a certain power. And in this example, the power is 4, but you can have any positive, negative integer, and you can also have 0. And I'm going to be showing you guys all those examples right now. So, alright, how would we solve this problem? So, I told you guys that this number basically means the same as 28,700. Don't believe me? Well, I'm going to show you guys how to do that. So, you have 2.87 times 10 to the fourth power. Alright, so we need to solve this baby right here. So, 2.87 times 10 to the fourth power is 10, or excuse me, it's 1 with 4 zeros. So 1, 2, 3, 4. So 10 to the fourth power is 10,000. And I'm not going to explain to you guys how to do powers and, exponents and stuff like that because I'm assuming you guys already know. I don't think we need to jump back that far. So 2.87 times 10,000 is 28,700. And by the way, I'm going to show you guys a really lazy way to do scientific notation, and that's this. let me go ahead and clear this. So we can go ahead and make all those steps like convert 10 to the fourth power to 10,000 then times this by 10,000. But that's one extra step. And like I said, we are scientists now and we are lazy. So let's go ahead and look at an easier way. If you have that same problem, 2.87 times 10 to the fourth power, and you want to figure out in everyday terms what this number meant, what we could do is say, all right, whenever we have a number that's like 10 to the fourth power, all we have to do is take this decimal point and move it to the right 4 spaces. So 2.87 equals, times 10 to the fourth, of course, equals 1, 2, 3, 4. And whenever we don't have anything, we just go ahead and throw in zeros and check it out. This is 28,700. Pretty cool, huh? So it kind of saves you a step. You kind of draw these things that look like boobs, kind of, but oh well. So let me go ahead and edit and clear that out. And now let me show you guys. Remember when I told you guys that the exponents can be negative too? Well, whenever they have a number and they times it by 10 to like the negative fifth or something like that, that means that you have a really small number. So say you have something like, let me go ahead and change my colors up. Let me think of something. 5.26 times 10 to the negative 5. Well, the very first thing we need to do is 5.26 times and convert 10 to the negative 5. So again, I'm not going to talk you guys through how exponents work, but 10 to the negative 5 is 0.00001. So 5.26 times 0.00001 is 0.00004 zeros 526. So that's your answer right there. I kind of drew over my decimal point. So again, if we want to do this the lazy way, because remember we're scientists now, have to do everything lazy, 5.26 times 10 to the negative fifth equals 5.26. And whenever we have negative, just go ahead and move your decimal point to the left 5 spaces. So 1, 2, 3, 4, 5. Wow, I gotta work on my curvature there. But anyways, just go ahead and fill in those zeros where you moved it and check it out. 0.0000526. So that's kind of the lazy way of doing things, but hey, it saves us this step right here. So now the last example I want to tell you guys is about that zeroth exponent, because remember I told you guys you can have a positive integer or negative integer for your exponent, but you can also have 0. So if you have something like 6.9 times 10 to the 0th power, the very first thing we have to figure out is, alright, what the heck is 10 to the 0th power? And if you remember from like 5th grade math, anything to the 0th power is 1. So this pretty much means, alright, 6.9 times 1, and again, anything times 1 is itself, so this answer is 6.9. Again, I don't really have a lazy way of doing this because pretty much this is really lazy in itself. Anytime you have times 10 to the 0th power, just get rid of all this, and that's your answer right there, 6.9. So that is your very first physics tutorial. I hope you guys liked it, and again, I'm going to show you the lazy way. I'm going to show you like the technical correct way to do all this stuff, and then I'm going to show you like, the lazy way where you can get away with it. So it's going to be real fun, and yeah, I'm going to work on moving my decimal places, getting them a little bit better, and you guys stay tuned for the next tutorial. It's going to be awesome. So thank you guys for watching, and I'll see you then.